everyone. Myself Smita Ghosh from Smita's Mathematica. Today we solve JEE-MAIN Shift-1 6th of September 2020 question. Question number 5. Limit x tend to 1. Upper limit, upper numerator is 0 to 1 integration x minus 1 square cos of t dt, and the denominator was x minus 1 sine of x minus 1 is equal to 4 options are given. This is the question in the house of limit, and it is definite integral. Some definite integrals is given here. So just using Leibniz theorem and Leibniz formula to crack this limit. As we put x is equal to 1, then it become 0 form. So we may apply LH rule as it is 0. So just write down limit x tend to 1, numerator is 0 to x minus 1 whole square cos of t dt, and the denominator is x minus 1 sine of x minus 1. When we put the limit as x is equal to 1, then it becomes 0. So now applying LH rule with Leibniz form. So Leibniz theorem Leibniz theorem tells us that limit x tend to 1, differentiating upper limit minus lower limit. So putting the upper limit value, it become 2 into x minus 1 into x minus 1 square whole square into cos of x minus 1 whole square, and the lower limit putting, then it is 0, and then differentiate. So 0 and lower limit, after differentiation it become x minus sine of x minus 1 plus x minus 1 cos of x minus 1. Now putting x equal to 1, again 0. So it again 0 form. So now taking common sum, so it is limit x tend to 1, it is 2x minus 1 whole cube cos of x minus 1 whole square, divide from denominator we take common x minus 1, so it becomes sine of x minus 1 in divide x minus 1 plus cos of x minus 1. So now we put that is, it is sine x minus 1 by x minus 1, it become 1 here. So and this is cancelled off and this one becomes square, so it is 2. So it is limit x tend to 1, 2x minus 1 whole square cos x minus 1 whole square, and here we get some sine x minus 1 divide x minus 1 plus cos of x minus 1. So now put x tend to 1, x is equal to 1, so here we get a numerator is 0 here, and denominator it is 1 plus 1, it is cos 0 means 1, so it is 0. And here we reached, it is our required answer. and our option 2 is our correct choice. Now now it is the whole solution. Now some information about basic information and some formulas about limit. So what is limit? Now we just read what is the concept of limit. So starting with definition at first. So definition is what? If x tend to a plus f of x, and it is limit here. So if the limit goes to a plus and it is fx, and the right hand limit and the left hand limit x tend to a minus f of x is equal to L, and L is obviously finite, then it is the limiting value and L is called the limiting value. Then we say limit x tend to a f of x is exist here. This limit is exist here. So f of limit x tend to a f of x is equal to, we may write L, some finite number. So now the concept of limit. Now what is the concept of limit? We know the definition. Here we get the definition is what is limit. Now the concept is if f of x is equal to we just write 2x by x, where x is not equal to 0 and the domain is R minus for all 0. Here this is not applicable in the point 0, otherwise every point if f of x is equal to 2x by x, so we just plot down it is the x-axis and it is the y-axis. So here we get point minus 0.5, it is 1, it is 0.5, it is 1, and here is 1.5 and 2. So now it is the 0.2. So this is the line which shows x that is it is 1 2, it is the function, this function is shows in the line. Now the tending value that is tending, it is tending to x. If it is tending to x, then it is the clear picture of f of x is equal to 2x by x. Now limit x tend to a f of x is equal to L. We again plot it as it is just f of x. Here we get f of x and this is our a, as it is x tend to a, and here we get L, this is L here, so here is L. So now we say the right hand limit and the left hand limit satisfy, so it is the this is tending to as the limit x tend to a f of x is equal to L. So this curve shows everything. Now method for evaluating limit. What is the method for evaluating limit? Method of for evaluating limit. What is the method? How we evaluate a limit? We have indeterminate form. We have some indeterminate form. At first we study what is the indeterminate form. We have indeterminate form, which is 0 by 0, infinity by infinity, infinity minus infinity, infinity 0 into infinity, 0 to the power 0, infinity to the power 0, 1 to the power infinity. So if it is these are the indeterminate form. Here f of x by gx, if the two function, it is one is fx tend to 0 and gx tend to 0, then f of x by gx is tend to infinity. 0 by 0 form. This is called the indeterminate form. Now the determinant form is what? What is determinant form? So determinant form is fx plus gx tend to 0, f of x cross gx tend to 0. These are the determinant form. So here we learn the definition of limit, which is if a function x tend to a positive limits and the negative limits, right hand limit and the left hand limit is same, then it is called L, and we may say f of x at the point a, fx is exist and that his limiting value is L. Now the concept of limit, if suppose here is the function is fx is equal to 2x by 2, where x not equal to 0 and the domain is r minus for all 0 except 0, every numbers is here we defined fx is equal to 2x by x. As if we cancelled up, this become 2. So when we take f of 2, this is 2. F of here if we take f of 1, this is also 2. F of 3, this is 3 cancel option 2. So this graph plots the everything, and that is if we tend to the, it is tend to x axis. So it is x tend to a, f of x is equal to L. Now this limit is shows that here we plot x-axis and y-axis. So this one is the graph of f of x, and here we get a and it is L. A is what? A is tend to x limiting value where x tend, and L is the a final and exist value of f of x. So method of evaluation limit, it is two forms, that is indeterminate form is f of x by gx is equal to infinity, and determinant forms are f of x plus gx is equal tend to 0 and fx cross gx is equal to 0 or tend to 0. So here is some information about limit and some basic information and the solution of question 5 of JEE-MAIN. So any question, any query about this topic and this solution, you just comment me in the comment box. Thanks for watching my video. That's all.